Problem set 83, product rule with variables, power rule with variables. Now, fellas, when you have a base times a base, you add the exponents. And when you have an exponent to an exponent, you multiply the exponents. X to the sixth. See, two different answers. Base times a base, add the exponents, exponent to an exponent, multiply the exponents. The only thing now is, instead of just numbers, they're starting to use variables. They're using letters. It's still the same rules. It's not a big deal. It's really not. Let me erase this, and then we can get started. I'm going to do this problem right here, which is x to the a, y to the 2x, x to the a over 2, y to the 3x over 4. So you can only do base x times base x and then base y times base y. That's all you can do. So base x times base x is going to be addition. So this is x to the 1a times x a over 2. Well, isn't that 1a over 2? 1a over 2. Well, isn't that 1/2 a? Yes, it is. So this is x to the 1/2 a. Okay, what's 1a plus 1/2 a? Common denominator, 2 over 2a plus 1 over 2a gives me 3/2 a, right? 1 plus 1/2 is 1.5. Keep the variable. You're just adding the number out front. You keep the label, keep the variable. Now how about y? You have 2x, y to the 2x, times y to the 3x over 4. Well, 3x over 4, hold on a second. 3x over 4, isn't that the same as 3/4 x? Yes, it is. So 3/4 x. So 2x plus 3/4 x, man, that's simple. You got a common denominator. That's 8 over 4x plus 3 over 4x, which is 11 over 4x. Now, I think the way that they write it is y to the 3a over 2, like that, kind of sideways. Sorry, x, excuse me. X to the 3a over 2. And then y to the 11x over 4. Okay, these are the same answer. They're both correct. Whoop. That's an x. Everyone see that? It's an x. All right. So it's just variables. You just have to add the variables up with a common denominator. You already know how to do this. The only little tweak is that there are variables now. Now, what if we had another board? Yes. What if I did this one here? X to the a minus 2, y to the a plus 4, all over x to the a over 2, y to the 2a. Okay, rather than rewriting something like this fractional exponent, I want you to start seeing it as a over 2. That's 1/2 a. A over 2 is 1/2 a. You just have to read it that way. Now, when you bring stuff up or bring stuff down in a fraction, remember, you change the sign of the exponent. So what happens when you bring x to the a over 2 up? It becomes x to the negative a over 2. And what happens when you bring y to the 2a up? It becomes y to the negative 2a. See that? We just took these and we brought them up. So for these base x's, the only thing we can add are the a's. You can't add -2. These are apples, and this is like a banana. You can't do that. Apples to apples, and you cannot add that -2. So that'll just get added on. That'll just get tagged on to the end, okay? So really, it's x to the a, 1a minus 1/2 a, 1a minus 1/2 a. That's 1/2 a. because 1 minus 1/2 is 1/2. So I would write that as a over 2. That's 1/2 a. See? 1a over 2, that's the same as 1/2 a. And then minus 2, you have to tag on the end. There it is. You can't do anything with it. So we added the a's like we were supposed to. Now with these y's, base times a base, we add the exponents. So y, now what's a minus 2a? That's negative 1a, or negative a. And then plus 4, apples, apples, right? Banana here. So you have to add 4, tag it onto the end. You cannot simplify anymore. There is your answer. Okay? That's your answer. Now, they do this problem here. This is all on page 343. X to the a plus 2 to an exponent. So an exponent to an exponent, you have to multiply. So a plus 2 times 2. A plus 2 times 2, because it's an exponent to an exponent. So the 2 has to be distributed to each term inside. So that is x to the 2a, right? A times 2 is 2a, and then 2 times 2 is 4. X to the 2a plus 4. It doesn't mean x to the a plus 2 times, well, it does mean that, x to the a plus 2, but you can just distribute the exponent, and you don't have to do that. Okay? So let's do this one right here. X to the AB, x to the a to the b, and then y to the a to the b plus 2 divided by x to the negative a. Okay, so when you have an exponent to an exponent, you have to distribute. We are not doing this. We've already done it. This is the one we're concentrating on the bottom of page 343. So this is x to the AB. X to the AB. Exponent to an exponent, you multiply. Y to the AB plus A. Plus 2A. Because we're going to have to distribute, since it's an exponent to an exponent, this goes here and here. So it's y to the AB plus 2A. Well, Mr. Stroud, they both have ABs. You can't add those, though, because this is a base x and this is a base y. You cannot combine these two. But however, x to the negative a, let's bring that up, and when we bring it up, you change the sign of the exponent. So that becomes x to the positive a. Now, these you can combine, but a and ab are two different numbers. So it would look like this, x to the a plus ab, because when you do a base times a base, you add the exponents. So now we only have one base, and we have both of these things in the exponent, a plus ab, and then it's y to the ab plus 2a. Easy peasy, okay? And, well, that's the only examples they give you. I just want to make sure you saw that on problem set 83.